All right. So I'm going to talk about some more persistence mechanisms. The point of a persistence mechanism is that when they restart the machine, your malware will restart. So here's common ways to do it. The oldest, simplest way to make something start was just the startup folder. If you ask me, this is the only one that should exist. There's a folder, and if you just put a program in there, it will launch its startup. And if you just put a shortcut to a program in there, it will launch its startup. There's a folder in the All Users location here in Windows Start Menu Programs, and every time the machine starts at all, anything in there will launch. And then you can put another one in each user. User's username, app data, roaming, and all that jazz. That means when that user logs in, it will run. And if you ask me, these are the only two things that should exist, but there are 100 others. So these are easy. This is how honest programs like media players that want to launch some helpful thing in the corner will typically do it this way, because they're not malware, they're not trying to hide, they don't want to make it very difficult for you to find it and make it stop launching if you don't like it. They just put it in the startup folder. Then there's scheduled tasks. You can create them with the scheduled task tool and control panel, or you can use the command line. The old technique was at a certain time, launch a command. The later one is the SCH task command line command that gives you more options, so you can have the more complicated scheduled tasks that will launch only when the keyboard is idle, or launch after a delay, or complicated things like that. But both of these we'll use to make tasks, and the tasks will create job files in system root tasks, and those job files will have conditions, and they will get launched at certain times and certain dates as you choose. And you could totally make one that will launch, every hour. I know in Unix systems, well, actually it might have been Windows systems. I heard back when the Chinese hacked Google in 2010, around that, all the information came out about the Chinese advanced persistent hacks, and they said that they were putting malicious things on machines that would sleep for up to 3 years before waking up. And you could certainly do that with this process. And so that you would think you got it clean and make a good image and deploy it to all your machines, and then in 3 years from now, it will wake up and steal your data again. So it's really hard to get rid of infections like that. Then you can modify an existing binary. The operating system itself is just a pile of folders, same thing's true of Linux, it's just a pile of files. CMD is a file, Explorer is a file, kernel 32.dil is a file. So if you just change some of those files, then when the system boots up, it'll be launching a poisoned version of the file. So you would add malicious code to the file, then timestamp it, which we talked about before. The timestamp is one of the programs that will change the time. And typically what you do is you copy the time from other system files, because typically all your system files are like several years old. All your user files are this year, but the operating system was developed years ago. And when you install it from disk, all the system files have a timestamp from when Microsoft compiled the operating system before it got put on the CD you bought. So you don't, if you had a system file that had a timestamp of the current time, that would be a red flag, so you alter the timestamp to point back to the same time as the other system files. It'll still have the wrong MD5 hash though, and if it's a signed file, the signature won't work, because the signature is a hash signed with a key that you don't have. Yeah?
So do you typically always check the hash with all your time stomps and everything else? Just to make sure that's been altered or not?
You could, but it's not easy. There are automatic processes to check the file. Ever since Windows XP, and I think Windows 2000, there's been a system file checker. You can type sfc/scan now, and Microsoft will automatically check all the system files and see if they match. And if there's a tool called Tripwire you can use to take a snapshot of your machine and store the hash of every file, and then you can run it later to see if anything has changed. And that's typically how you do it.
Is the timestamp change the MD5 hash?
No. And this is very important. This is one thing I haven't done in this class, I've done it in others. If I make a file and then I copy the file with a different name, they have exactly the same MD5 hash. The MD5 hash only gets the data, not the file name, not the timestamp, not anything like that. Now, however, if you take a forensic image of the disk and take a hash of that, then it matters, because those bits are on the disk somewhere in the master file table, and they will change the forensic. That's why booting up machine with the evidence drive connected will change the timestamp on like the recycle bin, and that's enough to make the MD5 hash change. So that's why you need a write blocker. Yeah?
Is the timestamp isn't connected to the actual binary, it's like part of like the tables that are tracking where things are and when they got put there?
Yes, it's metadata in the master file table, and the actual binary is typically clusters out on the disk in a chain of clusters, so they're quite separate. And so for example, if you copy the file and put it in a different folder, it doesn't move any of the data, it just changes the metadata.
So the hash couldn't include it in the metadata, because like every time someone installs, it would be a different hash.
Yes, exactly right. Good. Anyway, so there's the game. You'd change If you change critical system files like Explorer, then you create all kinds of problems. The thing would crash. So typically they'll find some small file in Windows that doesn't matter. If you don't know that most of Windows is broken all the time, a lot of it is broken all the time, you just go to Event Viewer. A typical machine has hundreds of errors, just like your car. There's little things that don't work, but you don't care because you're not using those things. It's a little better in modern versions of Windows. I used to teach XP desktop support, and one of my homeworks was go in the Event Viewer and find an error and figure out what the error is. And there were always hundreds of them. And when I tried doing that recently with like Windows 8, and Windows 10, a lot of people actually had no errors in the event log, which I've never seen before. And I think the quality of Microsoft code has been improving. Yeah?
Or maybe they just have event viewer ignore the common things that they're not going to fix.
That's another option. It just depends on how cynical you are about Microsoft policies. Unfortunately, there's significant justification for both of those. But anyway, so the Windows file protection was the original thing that protected you against this. But it turned out to be easy to bypass, so they replaced it by Windows Resource Protection in Windows Vista and later, and this came along with a special new account, not system and not administrator, but trusted installer. And only the trusted installer account can change the list of the correct hashes. And that turns out to be more resistant to tampering. They made it so it's difficult for malware people to elevate themselves as trusted installers somehow, or maybe they just don't know about it yet. But anyway, they're getting pretty good at protecting their system files. But nothing is ever perfect, and if you install third-party software that launches, they can certainly mess with those files, and these Microsoft protections will not protect you. That's why third-party solutions like Tripwire would be good. And another solution mentioned earlier in your book is take the MD5 hashes from the suspect system and go find the original ghost image that was supposedly imaged from and compare it to that. And then you'll know if something has changed between the time this was deployed from a known clean image to this one, and that would be a clue. Then there's sticky keys. This has been around forever, I think since Windows NT or so. If you press the Shift key 5 times on Windows, it'll pop up a box because the idea is maybe you have a handicap and your hands shake. And so they say, oh, you appear to need our handicap accessibility option. And then it'll let you have a different kind of keyboard where it will like ignore repeated key presses or something. And the point of this is so people with physical handicaps can log in. And that means you can launch this before you log in. So, for a good time, you find the file that does this called sethc.exe and you replace it with cmd.exe. And now, before you log in, you press Shift 5 times and it opens a command prompt running as system. Because no one's logged in yet, now you have total control of the machine without logging in. You bypass the login. This is an old trick and it works just fine. You could in principle put anything there. You could even put Explorer there and then you get a start button on a desktop without logging in as system. So, and you can even do this during remote desktop protocol because you could be remotely connecting to a server and have shaky hands and they would like to offer you this option. So it's a tough one. It's been around for a really long time. Supposedly Microsoft has patched it in Vista and later, so you can't just replace that one file. I know when I used to do various companion Trojan attacks like this and they all stopped working around the time of Vista, but you can do a similar thing with the registry setting here. And that will result in the same thing. Not in years, not since XP. When we taught XP Desktop support, we made Trojans like this, but they quit working in Vista, so I took those projects out. Then there's a similar one, another thing in the general category of companion Trojans, where you put in a second file that is mistaken for the first file, is dill loader or hijacking. It used to be in Windows NT that all kinds of system processes were launched by just the name. If you type start run cmd.exe, you haven't really told it where cmd is. So Windows will now hunt for that file, just like Linux would, and it has a path variable that will hunt for it in C and C Windows and C Windows System 32, and then your profile, and then some temp file. So it's hunting for this file without knowing what it is. So someone could put a fake file earlier in the path and it'll run that instead of the real file. And so to prevent that, later versions of Windows started having defenses. And one of the defenses was the known dills registry key. In the old days, every dill would just load by just the name without telling you where it is. So you could just make a dill with the same name in a different folder. It would load instead of the genuine dill, making it trivial to inject dills. So to protect this, Microsoft put this thing here in the registry, known dills. And the known dills are all loaded from that directory up there, dill directory, which is system root system 32. So these dills, which are important Windows system processes like WinINet we were looking at earlier, always have to load from the known place C Windows System 32, which is what you want. The problem is, there are things that are not in that list. but that are still loaded. This is usually a problem with every Microsoft dispense, like editor space layout randomization. They don't really apply it to 100% of the system. So all you have to do is find the part. They haven't turned that protection on yet, and it's still easy to hack into. So there are other DILs that are used here, and if it's not known to be there, then it will try a whole series of hunting, where the application is loaded, system32, system root, current working directory, and on it goes. And the old technique, before they had safe DIL search turned on, would start with the directory where the application is loaded, and that's really great. This is how, say, the attack we used on Iran worked, Stuxnet. You'd have a file on a USB stick that we were going to launch, or you just put it there, and when you draw the icon to show the picture, just because you opened, when you plug in a USB stick, it will pop up a box showing you what's on the USB stick. It'll draw a little icon next to it, which might be a little image of a Word document if it's a text file or some other icon. The process that draws that icon uses a system DIL, and they put a fake DIL with the same name on the stick. And it would load the fake one from the stick because the directory where the app is loaded is the first place it looks. It doesn't look in the actual system files until later, and that DIL would take over the machine. So just plug it in the stick and having the box open, poof, your machine is already owned. Bloody awesome, no user interaction at all. And there were a whole bunch of those. That's why Microsoft had this safe DIL search mode available, which you can turn off, but if it's turned on, then it doesn't start quite that bad, although it still starts when the directory of the application is loaded. So anyway, there's...
That's crazy, because I know Linux, like, that's one of the things, it was like, you never put like current directory in your paths anywhere.
But that means you always have to have / when you launch everything, and that's a poor user experience. That's why you have to have / in Linux, because they don't put your current directory in the path, which is a whole lot safer. But this is one of the many ways, where Microsoft always has convenience over security, and now they have some complicated feature to try to compensate for that, because people now, if they hear, have the habit of start run CMD. They don't do C Windows System 32 CMD.exe, which is what's actually recommended in the Microsoft certification. But who's going to do that when for 20 years you've been doing start run CMD?
Yeah,
Yeah.
you can also, there's other ways you can persist like new locations.
Yeah.
In the Windows Explorer, you
Yeah.
just run CMD.
You can, and therefore you haven't really specified which CMD to run. It will now hunt through a whole series of places, and then it used to be a trivial attack in Windows XP. You could just put another CMD someplace and it'll run instead. Now it made it a little harder because of these defenses, but there still are ways around it. So the load order hijacking works if the legitimate DIL is not known DILs and it's not in the same directory as the application executable file, and the executable doesn't use an absolute path, it just has the name, and then lets the system hunt for it. And then one of these examples is this thing, ntshRui.dil, which Windows Explorer loads when it draws the desktop. So you can put a malicious version of that DIL someplace and it will get loaded automatically. So it's the same. These things have been around for a long time, and all the Microsoft defenses never seem to quite clean up all the exceptions. And all you need is one, the bad guys learn about it, and then your security is kind of shot again. All right. I think that's the last batch of iClickers. Yeah, all right. So which technique produces job files? All right, I'll quit at 30. All right, and those are scheduled tasks. They call them recurring tasks here, and they bear an extraordinary similarition to cron jobs, which is what they're imitating from Linux. All right. All right. Which technique uses app data? Quit at 30. All right. Those are the startup folders. They're in the app data. App data is a hidden folder in your profile where a whole lot of goodies are. All right.
That's in the user's directory, right?
Yeah. You see users, your name, app data. Yeah. All right. You press Shift 5 times. What are you doing? That's sticky keys. All right, good. And what does WRP prevent? All right, and that stops you from modifying system binaries. It's keeping some list of trusted hash values or something of the sort. So that's it for that. Let me stop the recording and then I'll see who won. Here's the recording. All right, and this is 121 chapter 12. All right.